So I wondered, how did the Scolibot come about?
Well, I guess we've got an interest in robotic technology generally, but this is a whole new area of co-robotics. So these are robots, there's two as you can see behind us, Katie. So these are robots that basically are designed to work safely alongside humans, mainly for industrial applications, so where you'd normally see guarding and interlock guarding, so if you basically open the guard, these robots stop, because obviously it's clearly a danger element. But with co-robotics, for example, this company say that 80% of the applications they work without any guarding. So obviously we saw that, we talked to surgeons that we work with and clinicians and saw a potential opportunity for use in theatre. But as far as we're aware, still today that opportunity has not been taken for this particular robot.
Okay. I wondered what differentiates the Scolibot from other kinds of robotic systems that we see in spine surgery?
Well, I guess, there's a few well-known robots. There's some that obviously mount on the spine and various others as well. But we believe currently, and clearly this is still very much a fairly early project in terms of research and development, but we feel that in terms of what it offers, in terms of linking with CT scan data, having basically a datum robot you can see on the left there, and what we call a tooling robot on the right, provides what we hope at the moment is a fairly unique and innovative opportunity for this type of surgery.
Okay. I wondered, how exactly does the Scolibot work?
Okay, so as you can see, as I said, we have two robot arms. So the robot arm on our left, as you can see, has that aluminium, if you like, extension, and that links onto one of the vertebrae. That vertebra is moulded as a laminar plate and locks basically onto that vertebra. The other robot in this instance, as you can see, has a drill mounted to the end with a torque converter as well. And what would happen is, once the surgeon would place the datum robot, as we call it on the left, into and lock to the laminar plate, and then once that's done by the surgeon, basically the software runs. There's CT scan data of the patient's spine within the system. So in terms of global and world coordinates, in terms of X, Y, Z coordinates, they are all relative now to that single datum point, which allows the robot to drill very accurately for the placement of the pedicle screws.
Okay. Do you know roughly how accurately the robot can move?
Well, the system specification says plus or minus 0.1 of a millimetre, so we'd hope to be somewhere in that range in the final application. So hopefully much more accurate than could be achieved, by any surgeon or any other human who's trying to do this kind of interaction.
Well, finally, I wondered, where do you think the future lies for this kind of robotic technology in spinal surgery in particular?
It's a very interesting question. I mean, obviously people are talking a lot about telerobotics. So I guess if we take quite a large leap into the future, you can imagine a system like this being controlled remotely over the net or by secure systems and lines, and basically performing operations remotely with the surgeon being in another place and obviously involved in directly controlling it in that manner.